A researcher claims that felons convicted of tax fraud spend less than 17 months in jail, on average. She takes a random sample of 15 such cases from court files and finds that the mean is 16.1 months, with a standard deviation of 2.7 months. Test the claim using a level of significance of 1%. You may assume that the amount of time served by these felons is normally distributed. So, what type of test will be used in this problem? Well, to decide this, it's best to identify first what the claim is. So the claim is that felons of tax fraud spend less than 17 months in jail on average. So to write that out more mathematically, we would say the mean time they spend in jail is less than 17 months. So we're testing a mean. So that throws out the population proportion test, and it throws out comparing two different populations test. So we're testing a mean. So test of a mean, and then we have to decide if we're doing a test using a t-distribution or a normal distribution. And that's decided by whether or not the test is using, whether we were given the population standard deviation or not. So in this case, we were not given the population standard deviation. We were only given a standard deviation of a sample. So then that points us toward a t-distribution. But it's still not guaranteed that we can use the t-distribution at this point. One other thing that has to be true is the central limit theorem has to be satisfied. And for the central limit theorem to be satisfied, either we have to be using samples that are large enough to begin with, being the border is 30, so more than 30, or we have to have a population that was normal to start with. And that would guarantee that our sampling distribution is normal, and then we could use the t-distribution. Well, our sample size is 15, so it's a small sample, so that doesn't help. But the original population was normal, so it says here, you may assume the amount of time served is normally distributed. So that guarantees we can use the t-distribution. And let's go through and check off the ones that count in Part B. So the evidence that justifies the use of the test, let's see, the sample standard deviation is not known. All right, so the sample standard deviation is known, so that's no good. There are two different samples being compared. Well, that's not true. The population standard deviation is not known. That is true, so we'll check that. All right, and the population standard deviation is known. Well, we just said that it's not known, so that's no good. The original population is approximately normal. Well, that was stated as true, so that's good. N and P and N and Q are greater than 5. That only applies to binomial distributions. And then the sample size is larger than 30, and that doesn't apply here either. So C and E are the ones that justify the use of this test. All right, now that we know we can use the test, let's go through and use it. So the claim is that the mean is less than 17. So there is no statement of equality there. That tells me that that claim falls under the null hypothesis. And I'll go ahead and mark it as the claim. The complement is mu is greater than or equal to 17, which you can use. That's perfectly fine. Although it's becoming a little bit more common to just put equals. So that's what I'm going to use here. So mu is equal to 17. Is the original claim located in the null or alternative hypothesis? Well, we put the claim in the alternative, so H1, the alternative. Next, what is the critical value for the given statistics, and what is the p-value for this test? Well, the critical value, that's not really the right wording here. Really what that means to say is the test statistic. So let me correct that. Okay, so to get those, we will use the calculator. And I'm going to scroll back up so I can see the information from the sample. All right, so turn it on the calculator here. We're going to use the t-test function. We've already decided that that's the most appropriate to use because it's a test for the mean with the t-distribution. We have statistics of our sample, so we're going to just leave that checked. Mu sub 0 is the mean from the null hypothesis, which is 17. X bar is the mean out of the sample, which was 16.1. Sx is 2.7. And n is 15. Then mu less than or equal to, or sorry, not equal to, less than, greater than, that's just the symbol that we're using in the alternative. And that symbol is an arrow you can think of pointing to the left, so it's a left-tailed test. Or you can just match the symbol, that's fine. All right, so negative 1.29 for my test statistic. And what's the p-value for this test? The p-value is given as 0.1088. Then what is the decision based on the given statistics? To make the decision, we take our p-value that we just found, which is 10.88%. So just changing it to a percentage. And I compare that to the level of significance. The level of significance was 1%. All right, so my p-value is larger than alpha. So what I state here, because the rule is if p is low, the null must go. So if the p-value is less than alpha, we reject the null hypothesis. But that's not happening here, so we are going to fail to reject the null hypothesis. So that means that's my decision. Fail to reject the null hypothesis. And lastly, what is the correct interpretation of this decision? So using a 1% level of significance, just restating what that was, because you can have different interpretations based off of different levels of significance. So using a 1% level of significance there. All right, so if you reject the null hypothesis, you're going to use stronger language. So you're going to say, is sufficient evidence. If you fail to reject, you're going to do language that's less strong. So is not sufficient evidence. So there is not sufficient evidence to, and this word is either reject or support the claim. And it comes down to where the original claim is in the hypothesis. So the original claim is in the alternative, just like we stated here. And when the claim is in the alternative, we're trying to support it. If the claim is in the null, then we're trying to reject it. And there's logic that you can use to walk through and show you that. But often it's much easier for students just to memorize a couple of facts and move on.